Good morning and welcome to all the present. Thank you for joining us today at this first webinar, Heat Pump Skills in Action, launching the Skills for Heat Pump Cluster. Indeed, this event is organized under the framework of different 5 projects. And this session wants really to mark the launch of the cluster. That is an initiative bringing together different EU-funded projects that are working to strengthen the skills and support the large-scale deployment of the heat pump technologies across Europe. Indeed, as Europe heat pump market conditions are continuously growing, it's clear that scaling up the deployment depends also on having a skilled and well-prepared workforce. And today, for this reason, we will explore how different projects are actually addressing this challenging through concrete tools, training programs, and innovative approaches to skills development. And I will maybe give here a brief insights of today's agenda. So there will be a short introduction done by me. Indeed, I'm Francesca Tamburini from the European Heat Pump Association and also a communication and dissemination leader for SkillsAFU. Then we will start with the presentation from the 3 different project representatives. So the first one by Marco Masini for SkillsAFU project. Then there will be a presentation from Wilco Rolfs from the Heatcraft Heat Pump Consortium. And then last but not least, from Herbert Tretter and Tadeja Jansalikar from Installres Consortium. There will be later on the Q&A session, and so if you have any question, feel free to add it in the chat, and the closing of the event. That said, we wanted also to give a little bit of context regarding the initiative. So, as we have said, at EU level, there is a very strong push to accelerate the deployment of the heat pump technology, especially under Fit for 55 and the Repower EU plan. However, one of the main bottlenecks we are facing today is really the lack of skilled professionals, such as installers, planners, and technicians. And this is why skills have become a key priority with several initiatives like the EU Skills Agenda, the Pact for Skills, that were also presented during our previous webinar together with the European Commission. And also the strong emphasis in the national energy and climate plans. And at the same time, we see many different EU-funded projects that are really working concretely on these challenges. Across different funding programs such as LIFE, Horizon, Erasmus+, of course. But many times these efforts are really fragmented, and this can lead, of course, to duplication, limited visibility, and difficulties in scaling the results. And this is also where the link with the Build Up initiative is important. Indeed, last week we were all together at together with the European Commission at the Build Up Skills meeting. That is a platform supporting skills and knowledge exchange in the construction sector. And the idea of the cluster is really to contribute to the ecosystem, connecting the project results and make them more accessible and impactful. So building on this context, we have decided to developing the Skills for Heat Pump Cluster. And the idea is very simple. So we simply want to bring together the projects, whether they're focusing on training programs, certification schemes, or practical tools. And the objective is to better structure and share knowledge that are already being developed. And of course, increasing visibility, facilitating exchange between the projects, and strengthening the link between the EU initiative such as Build Up. And instead of having isolated projects, we really want to move toward a more coordinated ecosystem to make easier also to scale up and replicate the approaches. And ultimately, the cluster can also act as a single entry point for stakeholders, whether it's industry, training providers, or policymakers. We would love to be a referent point. But that said, I will quickly go through the projects that are presented today. So SkillSafe is a three-year project funded under the LIFE program. And the main objective is really to upskill installers by developing common EU guidelines to ensure the safe handling of air-to-90 heat pumps to support manufacturers and installers in the different phases of an installation of heat pump. So considering the storage part, design, transport, installation, maintenance, services, and disposal. Then we have Heatcraft HP. That is again a 3 years project, a sister project of SkillSafe. And the aim is to strengthen the workforce that is needed for the heat pump deployment across Europe, and is really focusing on identifying the essential skills and gaps in the sector and developing a workplace learning curriculum to fill the gap. And lastly, we have InstallRes. That is a EU project aiming to simulating the large-scale demand for heat pumps in existing building. They are targeting 5 different member states that you can find here. So Netherlands, North Macedonia, Austria, Poland, and Slovenia. And yeah, in these 5 countries, alternative and innovative business and delivery models are tested, demonstrated and scaled up, mainly to support a simple and affordable heat pump rollout. And yes, so just last information before introducing the first speaker. We are using the Teams webinar platform. So as audience, you cannot speak, unfortunately, but you can write in the chat. So for any question, please feel free to write it directly in the chat, and including the name of the person you would like to refer the question, and we will take care. And yes, I think we can start with Marco. So Marco Masini is the CEO of Centro Studi Impianti e Manutenzione. There is a company specialized in training, consultancy, and technical support for refrigeration and air conditioning sector. Is a preeminent expert in the refrigeration technology, safety, and also EU regulation. And today he will present you indeed SkillSafe. And I will give you the floor, Marco. If you want to take control, you should be.
Yes, thank you, Francesca.
Thank you very much.
Taking controls. Hopefully this is working. Yes, okay, I have it.
Yes.
So thank you so much for the introduction. It's very nice initiative, this skills for heat pump cluster. I mean, we need really to upscale all the possible resources out there in order to be effective in making the faster deployment of the heat pumps in the EU market in such a way that we can get rid of the dependency from fossil fuels all around Europe, basically. And this is why we have been concentrated at SkillSafe on the basic problem that we have right now. We have different regulations coming together, and sometimes we get puzzled on how to adopt each of them, because at the end of the day, we know that there is the F-gas that is pushing us towards the new low GWP refrigerants. In between, among them, we have the R290, that is a potentially explosive refrigerant, and this is one of the problems that we are concerned about. And this is why the SkillSafe EU project has been taking responsibility for developing a guideline for the market in order to correctly managing this kind of refrigerant. But at the same time, we have to care about the fact that we want to have everything very efficient. So the eco design is so important as well. And we cannot forget the fact that we have to work first in a safe way, secondly in a sustainable way, and thirdly in an efficient way. So at the end of the day, we have to take care of everything all at once. And this is sometimes creating some confusion out there. The confusion is because the refrigerants. And so the heat pumps are up to now, they were A1, that means not flammable refrigerant, very safe, and nobody was caring really a lot about safety. But for the time being, since we've started working with mildly flammable refrigerants like R32, and there are more coming into the market, and now that we have been pushed to use and to adopt the flammable refrigerants such as R290, this is becoming really a key point to be and to work safely in such a way that we can, we can afford to have a sustainable solution and efficient solution. So starting from this, we went through a very nice working package that we have been given as a responsibility. CSIM, we are responsible for the risk assessment part of the program, and this is the agenda for today. I'm trying to be fast enough in order to provide you the hints and the flavor of what we are doing in order to take care of it. Sorry for this. This is the time that has been running off. Okay, and okay, let's start now with the first things that are important. First, SkillSafe Consortium has been just presented. The SkillSafe Consortium is a 4-partner consortium that is constituents are HEPA, European Heat Pump Association, then Daikin Europe, then NVKL, that is the Netherlands Association for the installers and contractors, and then there are us. We have been given the task to develop a guideline, as we said, and we already delivered, and it's available on the website, the first version of the guideline. And then we are developing more and more paper and material in order to provide the market with all the information the market needs. As far as us, we have developed the risk assessment section of the guideline. We have authored an hermetic sealing and maintenance at exposition papers. That is something that we are presenting today. And we have been presented to the Parliament a petition that has been responded from the Commission that says basically that we cannot forget at all the safety and health hazards that we have to they're taken to the market because of the propane heat pumps. So what we have is 2 regulatory words. So but we have just 1 technician on site. So we have to look at the F-gas certification for sure, because this is pushing towards low GWP refrigerants. But at the same time, we cannot at all forget that we are under the occupational safety and health legislation that is taking care of the employers and the technicians and the employees because of the framework directive 89/391, and then we have, of course, to take care of the ATEX directives, since we are creating whenever we put our hands and we open the circuit, we are creating a flammable environment, and we have to take care also of the ATEX directives. And because of the petition that we put to the Commission, basically what they said is that the F-gas certification rules do not in any way take away or modify the rules specified elsewhere. That means the directives for the occupational health and safety, and of course the ATEX directive for the workplace. So it's something that we have to take care about, and this is really the base plan on which we build our activity. Basically, we have 1 life cycle, because whenever we talk about the heat pump, we have 1 life cycle for that heat pump, but we have 2 distinct risk assessment regime. There is, of course, as Francesca said at the beginning, the full life cycle that includes storage and transportation, but then when we come to installation, there is the first risk assessment that has to be done in order to make a proper installation. Then we have the commission, the use, and of course the phase that is a very important one, that is the maintenance and repair, and then the commissioning. Let's look into the installation. Installation is when we're installing a heat pump that has a circuit that is not opened, and therefore the duty is taken by the installer and the worksite supervisor. So whenever we install a heat pump, we have to be very careful in selecting the right place to where we want to put the heat pump. And in the SkillSafe guideline, we prepared a risk assessment for this phase that is very important, because whenever we select one site, that is the site where we're going to have also the maintenance and reparation activity afterwards. Of course, in this case, the explosion risk is none, basically, because, of course, the manufacturers put their CE mark on the heat pumps. Putting a CE mark means that the heat pump is safe. All the product has been tested and has been designed and is prepared to operate properly in the site. And since that point, that means when until the point we install the unit, there is no risk of explosion, so there is no risk at all hazard for the installers. And the typical installation is done by the plumbers, technician, or generic electrician, and all these kind of people that basically do not have to care about the explosion atmosphere. They are just putting the unit and connecting the electricity and connecting the pipes, the water pipes, in such a way that the heat pump can properly work. Afterwards, when we came to the first maintenance operation, of course, the situation is completely changing. Let's suppose that we have to change a part, or we have to just connect, for example, the gauge in order to understand which is the pressure the heat pump is working at. We have to open the circuit, and the open is intentional, and therefore we have nowadays the employer of the company that is making the maintenance and the qualified technicians that is putting his hands on the machine, that is taking the responsibility for this operation. We have developed, and we are going to publish in a while, a paper that is providing some risk assessment for the maintenance phase. MPRAM means maintenance phase risk assessment matrix. That is a document that has to be fulfilled in order to make this activity to be performed without risks. And then, of course, the explosion protection document. That is something that is needed, and the employer is obliged to look at because of the directives, the social directive, that is the occupational safety and health directive. So it's something that is mandatory. It's not something that we cannot avoid. We can avoid. And of course, in this case, the explosion risk exists and is localized and pro tempore for the maintenance activity that we are doing on the site. The typical operator has to be, of course, F-gas certified and ATEX trained. That means that it has to know the risks and to operate with the proper PPE in order to address the risks in the proper way. So the point is that whoever fits the unit shapes the risk profile. And this is what is happening whenever, for example, you select a place to put the heat pump. You have to look at all the surroundings in order to be sure that the site is cleared, the ignition sources are absent, there is not an accumulation of refrigerant in the nearby, that the work area has been prepared properly, all the risk mitigation tools are available, etc., etc. So at the end of the day, even if there is a sealed circuit, the installers take the responsibility to make the risk assessment that is not delegable later. So selecting the proper site is preventing risks also afterwards, whenever we are going to have a maintenance happening. And remember that whenever we install the unit, everything is covered by the CE marking of the manufacturer. So the manufacturer is providing a sealed unit that is not putting any risk and any responsibility and any liability for the explosive atmosphere later on after the installation. So this is very, very important. It's one of the key points. And this is why the skill safe guideline in the installation is so precise. If during the discussion about this aspect, we had not just the consortium partner, but also more than 50 companies for covering basically all the market joining for discussing about it. And we came up with an annex that is basically looking at the documentation and see conformity check that has to be done at the beginning. then the permit to work for the hot works whenever it is required, the installation location compliance for, and we've seen some details regarding the possibility of accumulation, all these kind of things, of the refrigerant in some places, installation location compliance, work area preparation, signature barriers, verification, the proper tooling, this is an important thing, and the PPE, and it's important to be also ESD safe. That means that since the propane is very ignitable, and you can ignite the propane also with some electrostatic discharge, we need to work when we do the maintenance with an ESD safe, for example, suits or shoes. And usually we use a collar bracelet in order to connect to the ground, in such a way that there is no spark coming from our dress or our activity. That is the point. So we are hermetically sealed, but at a certain point in time when we need to make maintenance, we create basically an explosion protection area that is localized. Of course, it's pro tempore. But at the end of the day, we want to open the circuit because we have to do, for example, some maintenance. So the duty of risk assessment shifts, in this case, from the manufacturer that put the CE mark on the units to the employer of the technician that is going to do the maintenance. This is really a key point. And this is why, for example, we are discussing a lot within the consortium about how to change, because they're not properly written right now, how to change the standard, the technical standard, in order to come back to the condition that the unit is still back in the sealed condition for after the maintenance. This is something that is not clear yet in the standards. We are working on it. Down here, you can see all the directives and all the standards that usually are used in order to make the maintenance activity safe. And this is very important, that we pass during the maintenance activity, we pass from the responsibility from the manufacturer that is discharged when we do maintenance, because they were able to provide a safe heat pump when they sell the unit, and they are CE marked. Whenever you put your hands on the unit, the employer is engaged, and he has now the duty to have the technicians prepared and trained to make the operation, and then the technician that is the one that is empowered to do all the activities. That is specifically that he has to be qualified for the use of flammable refrigerant. He has to have the F-gas certification, and with the new regulation, you have to have also some training also on the propane, and it has to be ATEX aware, because he has to apply the maintenance phase risk assessment matrix that is going to be provided to the market at every intervention. This is very important. But basically, we have three roles. We have three roles that are completely different, and each of one has his duty profile, and none substitutes the others. This is very important. So the manufacturer can support, and they have to provide a manual, a user manual that is full of information on how to make, for example, the system sealed in the proper way after any maintenance installation, but they're not responsible for it. Okay, they have just to say about it, but the employer then is the one engaged, and the technician is the one empowered for making the maintenance. This is a key point. The ATEX companion paper that we are preparing for maintenance is looking at three different sets of standards. The first one is the 12,100, that is basically the risk assessment standards. Then we have been looking at the 17606, that is basically the installation standard for the flammable refrigerants, and then the one for the servicing and maintenance standard. So we have a basic set of standard that we may look at. Then, of course, our white paper is offering four different tools, let's say. The first one is the maintenance phase risk assessment matrix that is basically covering the hazard scenario that you can have during the maintenance activity. Then there is the zone sizing. This is a very important thing. We have, let's say, standardized some measures because it's not easy to go through the ATX calculation in order to adapt every time to the different conditions. We have divided the maintenance activity into sub-phases, so recovery, purge, component work, hot works, tightness, recharge, all these kind of things, and you have different risks according to the different activity that you're going to perform on the heat pump. And then we have some operational tools in the paper, that is the hot work permit, the PPE and tools matrix that is also included in the guideline from SkillSafe consortium. Then the explosion protection document that you're going to see in a minute to how it is going to be formed. And I remember you, the EPD is something that is mandatory from the directive. And it's not something that you can avoid to do, because otherwise you're going to have some risks afterwards for any problem in the maintenance activity. And then, of course, a logbook. We have taken 5 hazards that out of 10 that we have been analyzing in the paper, just to show you that any hazard can be of very high risks, but can be taken low by using the proper working conditions. For example, just look at the first one. The release during the refrigerant recovery is, of course, can be of very high impact, but can be taken low if we perform a full pre-recovery and we purge with nitrogen, and then we use the ATEX detectors at a very low level of a flammable atmosphere. Then may want to use the ATEX fan in order to dilute the air the flammable atmosphere as much as possible, etc., and use the PPE, proper PPE, etc. So at the end of the day, residual risk could be low. There are several activities that we have been passing through, and each of one has some instruction on how to perform it properly. Just want to show you some example, for example, of the ATEX zoning for the refrigerant recovery scenario. We have been developing the calculation for this kind of activity. So we have a recovery point here, and therefore we imagine to have a loose coupling. And therefore, going through all the calculation for the R290 at the certain conditions, we may determine that the zone 1, that is where the risk is higher because there is the presence of the flammable atmosphere at a very high level, is just 50 centimeters away from the hose. And then the zone 2 space up to 1.5 meters. So at the end of the day, we have to care about this zone, and we have to perform and to behave properly. Just want to show you the detail here. In ATEX standard, we usually talk about different size of holes, but the smaller hole that is given from the standard is 1 square millimeters, while in some study that has been done in the previous life project, like the life front, Mr. David Coburn discovered after a statistical analysis that the standardized, or let's say the most common hole that we may want to take in consideration for our equipment is just 0.5 square millimeters. So in this case, we have a loose coupling, and we deemed in this case to use a 1.5 square millimeter because, if the hose is not connected properly, you may have a hole that is bigger than the standard, let's say, brazing hole. Okay, so just to provide some hints about the calculation we've done for providing you with the correct distances, the job, and to use the proper tooling in the right way. What always goes into the maintenance work pack? Okay, first of all, this is going to be included in the explosion protection document that I was talking about for the employer. We have to make a pre-intervention risk assessment. Then in this section, we have to make the site-specific risk assessment, and we have to sign it for the technician that is going to operate on the unit. And with the maintenance phase risk assessment matrix, as I said, we can cover most of the problems out there. Then there is the hot work permit. This is kind of very important because not everybody is doing this way, but it's a standard in the industry. I mean, if you look at oil and gas industry, all these kind of industries, at the end of the day, you have a very standardized approach that is very close to this one. Basically, what we say is that it's mandatory for any brazing, and we have to confirm with three different readings, with the leak check, measurement, that after the purge we have a level of flammability that is less than 5% of the LEL. But it has to happen more than 3 times. So we have to measure it for 3 times, 5 minutes or after the other, because we want to prevent the risk of oil releasing R290. Remember, the oil, just when you empty a circuit, is releasing R290 that is within the oil. So we have to be very careful, because if you start making the brazing just after having released and purged the system, you may have a flame, an explosion, just because of the propane coming up from the oil. So then we want to have the fire watcher presented means that you have somebody else looking at your brazing work, because at the end of the day you cannot see, for example, a little spark happening just a few meters away from you, and you're looking at your brazing and a few centimeters away from the braze, but you cannot see all the rounds. And this is why we need the fire watcher, etc., etc. We have some backup slides for this, and you will be able to go through it. Then we have to use need to use the PPE in the proper PPE ATEX tools, and we have to check very carefully the post-repair tightness. And just one comment here: whenever you want to check for the presence of the flammable atmosphere, we need to have leak detectors that are ppm rated. Why we want to, if we want to check the post-repair tightness, and we want to check if the system is back to the condition that the manufacturer released the unit, that is below 3 grams per year, we need to have a leak detector that is rated for grams per year. So there are 2 different detectors. One is for a safety purpose, and the other one is for tightness purpose. So we have to be very careful about using the proper tools also in this situation. And at the end of the day, what we can see is that the F-gas is a floor, it's not the ceiling. So the F-gas is really the starting point, but it's not enough at all. And in fact, as I told you, the EU Parliament in the petition said it very clearly. The F-gas is mandatory, of course, because of sustainable, environmentally sustainable approach. Then we have the technician competence. Of course, we have a standard, as you know, for the competencies of the technicians according to EN 378. Then we have the ability to be capable to make servicing for the A3 refrigerants that is under the EN 378 Part 4, or if you want the latest standard in our sector is the ISO 5149-4. This is the state of the art. Remember that we have to always use and to refer ourselves to the state of the art. Then we need to have the ATEX awareness, because we are forming by ourselves because of the opening of the circuit some ATEX atmosphere. Then we need to be comply with the specific occupational safety and health training. This is on the shoulder of the employer, and the technicians has to be attending all the training for that. And then, of course, you have the skill set training programs that we are preparing, and they are going to be available on the website of the program. I want to close with the 5 things to leave with. First of all, we have seen that we have 2 regimes. Whenever we do the installation, whenever we do the maintenance, so the risk assessment is not the same. We need to do different risk assessment. At the installation site, when we select the place to install the unit, we have to be very careful in selecting the proper way, the proper place, in order to not create additional risks on top of the possible release of refrigerants. Whenever we do the maintenance, everything is on the shoulder of the maintenance guy and the maintenance employer. This is very important. Installation guideline, we have some guideline in the Annex F for the guideline that is providing you some tools in order to make the proper selection of the installation site. For the maintenance, we have this maintenance phase risk assessment matrix, and we need to do and to prepare the explosion protection document that is mandatory by law. Then we have to remember that manufacturer is not the employer and is not the technician. Everyone, as you could see, has a different responsibility, different liability, and different, complete different approach to the job, let's say. And then, again, training is the lever. Thanks to training, we can do a really good job in keeping our sector safe. Our sector has been safe up to now just because we could use not a dangerous refrigerant from a certain point of view. We had just the pressure risk. Now we have more than that. So we have to be very careful. And again, all the initiatives that we are looking at is trying to provide all the evidence about the possibility to do a nice job, a safe job without risking in our daily activity. So thanks so much for now. Francesca, back to you.
Thank you very much, Marco. And I will take control of the presentation. And I think, well, these are the glossary and the key terms, but we will share the slide afterwards. So yeah, if anyone is interested in this, this material, you will receive it by email. And thank you for the comments. We will have a look later in the chat during the Q&A session. Yes, I will start introducing now the next speaker, that is Wilko Rolfs. Wilko is the chair of Heat and Mass Transfer at Aachen University in Germany, and also honorary professor at the University of Twente in the Department of Fluid and Thermal Engineering in the Netherlands. His research focuses on convective transport processes, liquid films, phase change heat transfer, and thermal management, with application ranging from energy systems, heat pump, to electronics cooling. And I will leave you the floor, Wilko. So if you wish to take control of the presentation.
Thank you very much. I try now.
Does
it work?
Yes, it's working.
Can all hear me? And yeah, I
yes.
also have control of the presentation.
Exactly.
Yeah. Thank you very much for the nice and kind introduction. I would like to present what we have done in the last 1.5 years and what is our aim in the project Heatcraft HP. We are focusing not as a skill safe on the safety aspect, but on the efficiency aspect of heat pump installations, because we have seen a lot of times that the efficiency is not as high as it could be. There are many small and bigger mistakes done in heat pump installations. And so within the larger consortium, we aim now to actually develop tools as well as a workplace learning curriculum. And I will tell a little bit about what a workplace learning curriculum is later on. Yeah, on this topic of efficiency in heat pump installations. The presentation here, most of that comes from my 2 PhD students. So I have 1 PhD student in Twente at the university. He's Mert. He is doing the workplace learning part. And then I have Mohanad here in Aachen, who is doing all the programming. And I think if you look later on to the tool, and you can also try that by yourself, you have the chance to get like a first visual impression of what the tool can do and what we can actually teach with it. So yeah, why is that a problem? And I think that especially let's see the situation from Germany. We have in Germany roughly 50,000 companies installing boilers, and the problem is that they are not all skilled in educating or skilled in working with heat pumps. And the system that there is in Germany with apprenticeship is really difficult to actually have a major change in technology, because the knowledge is transferred quite slowly across let's say even the over ages or even in the 10 or 20 year time period. And that's more or less a problem. And I think there are a lot of companies coming up now to the market that try to solve these problems with training and with larger installation teams. I think that has a benefit for the society. On the other side, I think we also need to help the small companies to stay in contact and to actually have the knowledge. And we are working on trainings. To create trainings and to create online training material that actually helps. Now, yeah, that's one thing here with the piping. I think, yeah, the heat pump itself is usually not the biggest issue. It's not actually the unit itself, as was mentioned before, that there needs to be a refill of refrigerant or so. The major difficulties arise in the installation regarding the hydraulics. So the connection of the heat pump together with the house, and to get this in a suitable manner together, that's usually an issue. And more or less every house is a bit different, and every installation that has been done in the past in the house is different. So it always requires some kind of good design and layout. And that's the reason why we have to know what we are doing, and we have to, I would say, more or less get a little stomach feeling of what's the effect of what. And one other problem that we can see is that if we provide just like these kind of mandatory trainings, then knowledge is fed in a very fast and more or less efficient manner, but it doesn't last too long. So as soon as the person is sent back to work and he has to think about it, then there is like the question, how can he actually transfer the knowledge that he has learned into application? And that's actually the word already in relation to workplace learning curriculum, because the idea is not just to learn in a mandatory training and an off-site training session, but also to learn on-site where you're installing the heat pump in an efficient manner. Yeah, so a little bit on the reasoning. You can see here there's quite a lot of literature right now on going on and research going on in how efficient are heat pump installations. And I think that it's mentioned here that not even all of them reach the mandatory requirement for efficiency. And from my perspective, the mandatory requirements that we have in the EU are not even that high. So we can reach higher efficiencies with heat pumps. And so I think that's one major issue. And to understand what the size of radiators, for instance, is on the efficiency, or what how can we increase efficiency by increasing the insulation. So these kind of interplay is quite important to know, and also in order to discuss with the customer and also to teach the customer a little bit. So that's where our workplace learning curriculum sets in. So it is the acquisition of knowledge through participation in a training program, which is like embedded in the everyday training, in the everyday working experiences, usually with, let's say, some kind of trainer. So there's usually a team of people doing installations. And in order to teach the younger or less professional people by one professional, it's important that this professional is able to actually transfer his knowledge. And if he is doing all the difficult parts without talking to the less experienced people, they will never learn it. So if they are only there to carry the heat pump and clean up and make some drillings, then they will not be able to do the installation by themselves next time. So it's really important that the trainer, that is the person now being with the people who needs to be trained, has the right skill set actually to be a real good trainer. And that's why we think this kind of workplace learning curriculum, where we have tasks that should be done on the job, where you can actually see what tasks are important, that should be able to really train people at the workplace and bridge the skill gaps that are there. And of course, at the end, reduce the barriers for people entering the market, but also reduce the cost of heat pump installations. I think these are quite important steps. So in order to reach this, as I mentioned already, we have quite a big team here. You can see there are 3 universities involved. That is the leading university, the University of Twente. That was started, the project, when I was still professor at the University of Twente. Now, in the meantime, I moved back to Aachen University, where I've worked also before. And another colleague moved from Twente University to the Interdisciplinary Transfer University in Austria. So they are also involved. So these are 3 universities, and then there are companies involved like Central Register Technique from the Netherlands, the Heat Pump Academy also from Aachen. And of course, then we have two German companies, WIP and OHKW. They are both offering trainings and bringing everything together and working on the public relations. We have, of course, a European Heat Pump Association involved in this project. So first, what we did is mapping skills to look what kind of skills are required and where can we find these skills in other disciplines maybe. So that was the first step. And then afterwards, we have now a few recent updates on the project. I think that's very nice to see, and also something to discuss within the team right now here where we are. So the first study that we completed was, of course, a question of what are the main barriers hindering learning and the performance in the installation sector, what needs to be learned. And there we are actually acquired quite fast this topic of balances. So first we were interested in teaching people more or less the heat pump cycle, how this works and what are the basics there. But after the discussions we had in the first interviews, we really identified the hydraulic balances to be the main issue. And that's why we focused on them over the last year or even a bit longer now. The first part that will be published already is in Vienna this next month. It's a heat pump, European heat pump conference, where we present the results of this first study. I think that will be quite interesting. So the challenging is that we have like an issue with hands-on and practical training. That's really something which is needed. More maybe the theoretical training, which is also important, but which cannot solve everything. So that's why we come up with this workplace learning curriculum. And you can see here it's based on 2 different parts. The one part is like a kind of front-loading activities for which we create like a simulation-based training. And the other one is an on-site workplace learning activities. And it's a bit different to, let's say, installer trainings where installers are trained even on like maybe the real heat pump, but within the environment of, let's say, maybe the manufacturer. And these kind of trainings are good. It's like a bit of hands-on, but these hands-on activities need also to be in a real workplace, meaning at a customer's basement or where the installation of the heat pump is. And that's why we are working on the workplace learning curriculum. So let's first go through this front-loading activities. Here's a web page. I can recommend that you can also have a first look on that. It's not all yet finished, but a few things are there that are nice to see. And I can also put a few links later here in the chat where you can have a own look on what we are doing and how we can create trainings. So the interesting part is because the regulations are different in different languages, we can do that actually in the languages that are now employed in the project. So we can create learning paths in German, in Dutch, in French, and in English. Of course, you can always use the browser to switch to any other language, but usually there is country-specific regulations, country-specific norms, and that can be included if we make the languages a bit more specific. So trainings are not just translations for the different countries, but can also include country-specific information. Now, we have right now on this website 2 tools, like 2 simulators, which help a little bit. The first one is the heat pump simulator, and the second one is the hydraulic balancing simulator. Let's first look at the heat pump simulator. I think it's quite impressive, but also a massive image that you can see here. And that's the final and version, or not final version, but the version that contains most of the information and parameters that you can actually change. You have the chance to actually first start looking at the outdoor temperature, learn what a norm or a reference outdoor temperature for a specific city is, to learn where to acquire these different temperatures. For Berlin, for instance, or also for Aachen and other cities, we have specific norm temperatures. There is like a room temperature, definitely, and there's an outside temperature. And you can specify them. You can specify the norm temperatures for different rooms, like living room or bathroom. And then here in this simulation tool, you can play with the radiator and the temperatures for the heat pump. And you can directly see what is the effect of the radiator sizing on the heat pump performance. And in the next step, you can also work on like the pre-valve setting of the heat pump. And the important part here is that what you can see is too much. So it's not really something where you can start with, and you can start with learning. And for that, we have introduced here some kind of learning curves and learning tutorials. And the aim is to create for each learning task that you want to teach, for instance, the influence of the norm outdoor temperature and the importance of the norm outdoor temperature on heat pump designs. And then you create, or we have already created like a guide which has a few different steps in order to teach people what the importance of the outdoor temperature, norm outdoor temperature will be. And the same will be done for all other effects. So you have guided tutorials, for instance, for the importance of the air exchange rate, of the thermal building insulation, of the radiator size, or also on the valve. So we can create those different parts. We cannot create them for installers, but also the aim is to have that for energy consultancies, for salespeople, and also for like the normal household people that are installing a heat pump. So the knowledge is also transferred on different levels in different depths, because I think a homeowner does not need to know all about the required norms that are important, but an installer, for instance, needs the information on what norms do those specific parts rely. So that's why we aim for different levels here. Yeah, this is also for the room temperature, and this is for the radiator valve settings. You can always see directly the influence on the COP. So if you make any changes in the system, reduce the supply temperature or change the outdoor temperature, you immediately see a response on the COP, and you also see what type of temperature levels are set in the system. So what is the temperature, supply temperature? What is the return temperature? And you get a feeling of how the system actually behaves and acts. Now, the second level is in the hydraulic balancing simulator. This is actually done to have not only one room, but multiple rooms with different pipe sizings in order to teach the interaction between different rooms and different radiators, to also get an understanding of why you have to change the pre-valve settings. So that's really technical, but it's all aimed to be done with the learning path and then integrated in the workplace learning curriculum. On the website, there are also a few tutorials and also information on different contents. So we have show a little bit of understanding of heat transfer. How does heat transfer work? Why is it always from hot to cold? We go a little bit into the terms of resistances to calculate heat fluxes, to get an understanding of that. Why do you have internal resistances on the air side, through the wall, and then on the outside? So this is also what we teach. And so we try to give people a bit of physical understanding that is required in order to understand actually how heat pumps work. What happens with the building's temperature, or what happens if you have multiple rooms that you heat. So different scenarios that we can actually play with and work with. And there are also quizzes involved, so you can always test your knowledge and check whether you have understood everything. And yeah, we have also a good quiz tool to actually create quizzes based on existing learning material. You can directly create a quiz of 20 or 30 questions, which then can be employed into a training program. Yeah, so that's actually our aim. Why is the heat pump not working, and how can we actually fix that? Usually the problem is not that the heat pump is actually not working. Usually the heat pump is working, but the problem is that the heat pump is not working very efficiently. And this is something that you can see at the end on your electricity bill. and that we see globally, or let's say on EU level, on the electricity consumption during cold winter days. So what we're doing now is we try to integrate this into national frameworks. We try to actually get a skill recognition. That's something very strong what we do in the Netherlands. And of course, then have some introduce the tool and the training also in national qualifications. And with that, I would like to thank you for your attention and hand over back to European Heat Pump Association. Thank you very much.
Thank you. Thank you very much for the presentation. I will take control back. And again, if you have any question for Wilco and related to the presentation, feel free to write it in the chat, and we will have a look at it later. And I'm going now to quickly introduce the next two speakers coming from the InstallRS consortium. So we'll have a short presentation before from Herbert. There is a senior expert in renewable energy, focusing on integrating innovative technologies for decarbonization, promoting energy-saving measures, and preparing reports on financial support for green electricity projects. And then we will have a presentation of Tadeja, that is a researcher at the Joseph Stefan Institute Energy Efficiency Center, where she works on projects focused on sustainable energy solutions. And her work includes research, stakeholder engagement, and preparing analysis, modeling, and strategic documents. So I will leave you the possibility to take control of the presentation. Voilà. Okay.
Thank you very much, Tadia.
Thank you.
Thank you very much, Francesca. I'm Herbert Stretter from the Austrian Energy Agency. Good afternoon and a warm welcome. I will now introduce the last of the three projects. This is InstallRS, an European project, live project. We are also in the middle of our project. It's a 3 years project, and it concentrates on okay. So it concentrates on heat pumps in the built environment. I see it does not work to move forward. Sorry.
No problem. You just should be able to navigate using the arrows at the bottom of the screen where there is a number of slides. You should be able to change them. Otherwise, I can change them for you.
I think I have a problem here too. So now it's working out.
Yes.
Sorry. Okay. Perfect.
No problem.
Yeah. So we are concentrating on the built environment, and we are concentrating on phase out of oil and gas mainly. And we are developing tools and materials to help implementers and investors to phase out those fossil fuels. And I will start now to introduce the project. So what are the goals of the projects? We want to stimulate large-scale demand for heat pumps in existing residential and commercial buildings. And we have 5 partner countries where we focus on those building types with a high scale-up and replication potential. And this is also where we have a total of 12 real-life demo sites where we test different technical and solutions and business models. And we want to learn from that and test different approaches and finally come up with replicable and scalable and affordable technical solutions and business and financing models. And for that, we work closely with the implementers in the 5 countries for developing tools and resources for the practical implementation. And this will be presented later by Tadia, what we are developing there now. We have 5 countries, this was already mentioned, and we have Housing Europe in our consortium. So that's a housing company or association on the European level that does the communication for our project. And in every of our 5 partner countries, we have mostly 2 partners, 1 partner that concentrates on the daily project work, And the second partner is the investor who realizes the real life projects, the demo sites. And here you can see the partners. So we have business partners, for example, Chronotherm, it's a heat pump manufacturer in Slovenia. In North Macedonia, we have a wholesale trader of air-to-air heat pumps. In Poland, we have Veolia as partner, who is a big consulting and investor. And in the Netherlands, we have one partner, which I will show on the next slides. And in Austria, I will also show some details what we are doing there regarding the showcases. So to start in the Netherlands, here we have a lot of row houses where still a lot of gas is used. So our partner, the heat transition makers, collaborate with municipalities in order to phase out gas, and the municipalities are responsible to make plans and realize this. And our partner here, for example, offers digital platforms to help the end consumers to find the suitable heat pumps for the houses, and also get some information how much a heat pump would typically cost for the situation that is given there. And then he can also ask for 3 offers from local installers. So all this information is on the platform, and this should help to use this window of opportunity as long as this partner helps the end users and to switch away from gas. So this is one case. On the next case, this is the Austrian example. Here we concentrate on multifamily buildings. The partner here is Sozialbau AG. That's one of the biggest housing companies in Austria. They have more than 800 houses. More than 300 of them will not be connected to a district heating grid. And those buildings also mostly have decentral gas boilers. And here, this company is a little bit special because they have their own installation company with 40 installers, and they target one house by one. And here on the right-hand side at the top, you see one of the worst cases of their building stock. Here the centralization of the decentralized gas boilers is done via the facade. This will be insulated later. And in other cases, in many houses, there are central chimneys connected to every flat. And here the centralization is done via the flue gas chimney. For example, in the attic is then the heat pump. And another case that's a very low invasive solution is the facade activation, which can be seen on the bottom left picture. Here the existing heating system remains in the flat and is mostly not used anymore. And this small activation helps to heat and also to do some temperature control during summer. And there's a third type of projects that are being developed, that's energy grids, so neutral temperature networks. There are 2 of them, and one of them we will have as a showcase. So that's the kind of projects we are implementing and monitoring the performance, and also we have some quality assurance to ensure that the projects are sound. And we also have 2 publications that are available. The links are here on the slides. The first one concentrates on technical solutions. This catalog is targeted at uninformed end users, and they can quickly get an overview which solution fits to their buildings, depending on navigators that ask some yes or no questions. And for every, let's say, element of the heat pump cycle, you will be guided to the pages where the information can be found for the solutions that fit to your case and under the circumstances you have. The second catalog is showing 12 different alternative business models. And here you'll see a table where the business models are compared. On the one hand, from the view of the business model provider, and on the other hand, in the view of the end user. And here several specifics are compared. For example, who takes the financial risk or the technical risks or the performance risks, and who buys the electricity, who takes the behavior risk, or who owns the plant typically. So this is also a catalog that shows to potential providers what is relevant or how this business model works, and there are also real life examples for each of these business models in this catalog. So that's all from my side for now. I will now hand over to Tadea to show you what we are developing regarding tools and materials. Thank you very much.
Okay. Thank you, Herbert. I'll now take control. I'll just, I can't move them either. Okay,
Yes,
it's fine.
perfect.
It's fine, okay.
Yes, it's working.
So my name is Tadea, and I will present the tools and materials being developed within the project, focusing on how they support users in practice across different stages of the heat pump journey. Okay, let's move on. Okay, so first off, I would like to briefly highlight the overall approach behind these tools and materials. The main idea is that they should not remain only for the purpose of this project, but to be used in real practice also, and also after the project has ended. Another aspect is flexibility. The tools are designed to be adapted to national conditions, since each country has different regulations, markets, building types, and so on. At the same time, we also develop EU-level materials. This creates a common foundation while still allowing local adaptation. Part of the content is also tailored for the training purposes. This means the tools are not only used directly in the project, but also supports the knowledge transfer. Importantly, these tools are developed with with input from national and EU level stakeholders, ensuring their relevance and practical applicability. And finally, we rely on collaboration with organizations at both EU and national level. These organizations are encouraged to host the tools and training materials on their platforms, which helps ensure wider reach, long-term use, and real impact. Okay, now let me briefly introduce the install RES toolbox called the Fast Track Scheme, or FTSE on short. The FTSE brings together different tools and materials in one place. They support users through the whole process, from awareness to decision to planning and finally use. The main goal is simple: to make things easier, support better decision, and speed up the use of heat pumps. The tools and materials were built through a collaborative process with partners in the project across different countries, collecting feedback and practical insights. The toolbox includes different types of materials, such as digital tools like cost calculator, simple guides, fact sheets, decision tools, communication materials, and real-life examples. Together, they give support to both professionals and end users. Okay, so the FTSE toolbox is structured along a clear roadmap with 4 levels, each level corresponding to a stage in the user journey. What is important is that each tool has a specific role and timing. So at level 1, Users often have little or no knowledge about the heat pumps and may even be skeptical. The goal here is to build trust and understanding. The fact check addresses common myths, for example, like heat pumps are too expensive, or they don't work good in older buildings, and etc. Then the heating matrix provides a simple overview of which systems are suitable depending on a building conditions. And communication tools help explain the benefits in an accessible way. Okay, so next off, at level 2, users are already interested but need to make a decision. The cost calculator is a tool that allows comparison of total costs across different systems, including investment and operational costs. The navigator helps users understand different financing and business model, which is perceived as a barrier. Additionally, technical concept and best practices examples provide inspiration and real-world insights. So the goal here is to enable informed and confident decisions. Okay, at level 3, the users has already decided to adopt a heat pump. Now the challenge is implementation. This is where many projects may fail or become too expensive. The PTC toolbox provides structured tools and guides this phase, focusing on reducing costs, avoiding unnecessary interventions, and ensuring high-quality implementation. Okay. Now let's take a closer look at one of the tools in the 3rd level, the refurbishment roadmap for heat pump readiness. The main idea is simple: to make buildings ready for heat pump with as little intervention as possible. This means avoiding deep and expensive renovation where they are not needed, and focusing instead of a simple, cost-effective improvements. For example, this is like optimizing the system, adjusting control, or improving hydraulics. And only if needed, more complex measures are added. This approach helps reduce cost and makes implementation faster and easier. The guide will also include real-life examples that will show how this works in practice. One example from Austria: the main challenge there was how to carry out a full energy transition while the building remained occupied. So the approach was step by step. First, the focus was on the building envelope, such as replacing windows, improving insulation, and refurbishing empty flats. And already this reduced the energy demand across the whole building, even for the flats that were still in use. Then in the second step, the building was disconnected and switched to a renewable system. This is a heat pump combined with a solar PV. The occupied flats are upgraded gradually to avoid disruption for residents. The results are strong. Energy demand was reduced even at the first phase, and this example clearly shows how a step-by-step approach can make existing building ready for heat pumps. But for more detailed info, follow the project as the materials are still being developed. Okay, so now let's move to level 4. This is the last level. The focus is on making the system work as efficiently as possible. So after the installation, the focus shifts to operation and optimization. The goal is to maximize efficiency and reduce costs. This includes something like smart controls, integration with renewable energy, and adapting operation to electricity tariffs. So these measures can significantly improve performance and reduce operation costs. Okay. After going through all the levels of the PTC toolbox, the key takeaway is that PTC transforms what is currently a fragmented landscape of information into a structured and user-friendly landscape to support the system for heat pump deployment. Instead of isolated tools and scattered informations, PhotoCell brings everything together into one coherent framework that supports the entire journey from awareness, decision-making, implementation, and in the end, optimization. It integrates technical, financial, and communicational aspect into one system based on real-life experience from demonstration project. Also, importantly, it is co-created with stakeholders, tested in real-world conditions, and designed to be practical, scalable, and relevant for today's market. And also with the PhotoCell, we address key challenges across the full process of switching the heat pump-based systems. At the same time, we follow a collaborative approach, complementing other initiatives and building synergies with other projects. Okay, that would be all. Thank you for your attention. If you're interested in the content that is being developed, please follow us on LinkedIn or on the webpage. Thank you.
Thank you very much. Thanks again to all the speakers for the presentation. As we have indeed concluded with presentation, and I've seen that in the chat the Q&A session already started, maybe we'll keep just a couple of questions from here that I've seen are not answered yet. The first one, I guess, is for Marco, as he's mentioning R290, so the refrigerant we are addressing in SkillSafe. And there is a question about certification. So if it's needed a certification for working with the R290 at the moment. Marco, I don't know if you want to comment.
Yep. As I said, for sure you need an occupational safety and health training. That means that you have been trained for handling the flammable refrigerants, and this is a basis. Then, of course, you have to be a competent person. According to the EN 378, you have to be qualified according to the standard that is the EN 22712. But if you're not, it's important that you take the training from your supplier and from whoever is forming you as is training you as a qualified technicians. The F-gas in this case is not yet a mandatory, because it is going to be such as that by 2029. The F-gas regulation is demanding for trained technicians to be trained according to the new scheme starting from next year, 2027. But according to the fact that each member state has provided you with the training certification schemes in their own country. So for the time being, again, the OSNH basis and a principal training for heat pumps. This is the basic.
Thank you very much, Marco. And another question, I think, coming after the presentation of Wilco is regarding the training. And if they are covering also air-to-air heat pump systems. So, Wilco, I don't know if you want to specify it.
That's a good question. And I think for the hydraulics, that's not that much of an issue. At the end, the air-to-air heat pumps, they are like, the system is a bit differently designed. I think in terms of heat load calculations, you can definitely use the system as well. So there is quite an overlapping, but we are not directly working on air-to-air heat pumps here.
Okay, thank you for the clarification. As I don't see other question in the chat, maybe we'll ask the last couple of questions also to be on time with our webinar to Herbert regarding the project mainly, where will be available the results of the project that you have presented?
We have a project website, but the main goal is to have our materials and tools to have them on platforms that are existing and known, for example, on the European level at your organization, or the European Heat Pump Association, or at Europe Heat Industry, or Europe On, or DCP Europe. So that's our advisory board members. And we also plan to have the materials and tools available on national platforms that are well known from professionals. So we are collaborating with those stakeholders in order to keep those tools alive and to also have them for trainings and so on. Yeah.
Thank you. Yes, indeed. EHPA is part of the advisory board, so we will be happy to share and promote also more the results when available. And maybe Tadea, I can ask a last question to you regarding the main barrier maybe that we see in the large adoption of heat pumps. So we have seen skills, of course, that are one of the main ones. What are the other main barriers that you see? If you want to comment something about it, the floor is yours.
Okay, the main barriers are still high upfront costs, complexity, and decision making, and the fact that many existing buildings maybe are not fully ready. Also, there are challenges with awareness, skills, as we already mentioned, and maybe also the coordination between the parties, stakeholders involved. I think which we try to address with the tools that are being developed in the project. I think that's it. That's all.
Yeah. Yeah, but from my perspective, it's mainly a financial issue. So heat pumps, at least speaking from Germany, are very expensive. So if you have a working heating system, it's like it's not worth switching to a heat pump system. It's not that you can save money with that. So I think the main issue is really on the financial side. Even if you
yes, also
if
that
you know
also
everything
that.
about the heat pumps and you are you're aware and you think, hey, that's a good alternative. If you look at the pure numbers for nearly irrespectively if it's a single family house or if it's a multi-family building, you will not do that without the need. So you will never install a heat pump if your system is still running.
Mm-hmm.
Yeah, thank you. And this is also something we have seen many times and that we are discussing a lot at the association level. And for another project that we are running for the European Commission, indeed, we have also analyzed many different barriers that we are encountering. And yes, the financial aspects is crucial again. So we will work a lot also to try to tackle this problem and this challenge and to find solution also with the government and our European level. Thank you very much to everyone. I think we have arrived to the end of the event of today.
Yeah, I do have another question. I think that the main question that we should ask here is also how can we cooperate and work together? So I think that's something maybe that we should, at least the people of today, the speakers should again meet and think how we can join forces a little bit better.
Yeah, true. Yes, indeed.
That's a very good idea.
Yes, the launch of the cluster was really a first little step, but we will follow up absolutely to really work on it. And also during the meeting at Build Up, I know there will be the possibility probably to build a community of practice on heat pump. So this could be also another path. But we will indeed follow up, and more events and activities are coming as the cluster has just been launched. Here I have included the website and the main references for the 5 projects that at the moment are part of the group. And I just want to thank you everyone to connect and especially the speakers for taking the time to present today the great work that you are doing in your projects. And more events will come. So if you want to participate to similar webinars or workshop in EHPA in general, we are always very open to stay connected and work together for organizing similar events. Thanks again. Thanks also to my colleague Sofia for supporting me and for organizing the events together. Yes, we can close the meeting, I think.
Yeah, thanks so much.
Thank you very much. Thank you. And all the
Thank you very
material will
much.
be shared. Thank you again. Have a good afternoon.